embracing electricity 4.0. This is somewhat also related to Industry 4.0. The overall how the 4.0 is driving the industry, including the utilities. So when we talk about electricity 4.0, it's a combination of core technologies in terms of the core power, transmission, distribution, generation, the equipment, the transformer, the switchgear, substation automation. And automation is basically the substation, the control, relay protection, the SCADA, and of course the digital is which is on the asset performance management, work performance management. So all these three types of technologies we are going to merge in electricity 4.0, the way industry 4.0 also, where it is the core technology and then the digital and the new automation technology. So 4.0 is a modernizing of urban grid with core technologies, automation, digital, all the three together. And then we see that the entire system works in cohesion in real time, and also improving the performance of whether it is generation, transmission, or distribution, and feeding power to the urban grid, to the smart cities, to the areas where it needs very reliable power. So one example is advanced distribution management system. So where on one hand you have the ADMS, the SCADA, the OMS, the DERMS, distributed energy resource management, where we do the analytics basically to ensure that we have the power available to the consumers, to the prosumers who are also producing energy, for example, solar rooftop. On the right side, you see the enterprise systems we have to have, whether it is CRM, workforce management, the asset performance management, of course, the business intelligence, field devices. So these are important. We need to, and we are integrating both the verticals basically through digitalization. This is what is going to also be in the urban areas, in the urban grid, very important to combine these two verticals, one on the enterprise side, the other one is the core SCADA, the power systems, the distribution systems. So that is what is important. Going beyond that, as I showed that it's going to be also distributed energy resource management. Whether it's urban area, city or state or country, we'll see huge amount of distributed sources. It can be solar, it can be wind, it can be the conventional one, the fossil one, and also the storage. So at the same time, on the load side, you have the EV chargers. So how you manage all these different sources of energy as well as consumption of energy. So that is how we do with the distributed energy resource management. So this is a technology where we overlay with including and on top of the SCADA, the conventional SCADA. So this is what the future is. And this is basically to ensure that the power, the energy is available, it is reliable, the grid is reliable, and also it is efficient in terms of energy, delivering energy to the consumers. So this is one example of how in future, so there are a lot of big consumers, whether it is industry, commercial, they're looking for how to achieve net zero, carbon neutrality. So for that, what they need is probably in the building or in the factory, in the urban areas, rooftop solar, and also have the energy efficiency, energy conservation program, but at the same time, energy storage to store the energy so that whenever there is grid power not available, it can be used, microgrid. And of course, power quality, very important because of load profile changing and also a lot of reactive power compensation, issues, challenges coming from the grid. So how do we manage that? And of course, getting the renewable energy from the grid. And to achieve the carbon neutrality, they're also looking for IREX. So whatever shortfall you have between the conventional energy and renewable energy, that you can have IREX, so that you can say that your facility in the city, in the urban areas, it is fossil fuel free, what you operate with fossil fuel free electricity. This is not so easy as it is seen. So here we have to also improve the performance efficiency. So that's why we also have the entire system connected with the data platform, with the AI ML application layer, where it is forecasting the energy which is produced in the plant, in the facility, in the building, but at the same time from the grid. And how do we, when it comes to electric vehicle charging infrastructure, so here again, it is not just the charging infrastructure in the vehicle, but also you see the driver, the traffic, the passenger. So all the information system, they are connected, integrated, and they are optimized in real time. So having the power available, having the green power available, having also, so this is an example of flash charging technology where the bus is getting connected 20 second, it is getting top up charged. So this type of technology we are bringing in the electricity 4.0, and it's getting integrated to the grid. So that was the flash charging and the bus stop, but here you also have the depot where you have large number of vehicles. So this similar, it is applicable for the cars and other two-wheeler, three-wheelers also, but here it is a bus where it is, you have the fleet charging, and then it is getting charged for the fleet of electric vehicles we are seeing now in the cities, urban areas. Another example of green power is also the hydrogen power. So here you see this is a hydrogen fuel cell based power backup. So it's like a diesel backup instead of diesel DG set. So this is a hydrogen fuel cell based. So it's a green power. So you can have a green hydrogen, and then it will be in future acting like a backup power instead of diesel. And finally, also getting all these data from the assets, integrating them, having a control center where you can do the asset monitoring, and also the work performance, workforce management. How do you engage the utility workforce for the maintenance, repair of the system, so that the power is available for more time and downtime is reduced. So here again, it's not just the conventional, but also here the AI ML applications are used to predict the asset performance, asset health. And for this, we also need the infrastructure, the communication infrastructure, and especially in power, we know that it's a very real-time scenario. So we need to have very highly reliable communication system where it is, let's say, wireless mesh technology. So what we have also in as Hitachi Energy. So this is a technology which is the availability is 99.99%. So we can't always depend on the public communication backbone. So this is a new extended backbone with high reliability with communication technology. When it comes to asset, as I already talked about, asset performance management, how do you make the asset more the life of the asset we can increase, extend with the sensors, connectivity, SCADA, and finally having the asset performance, asset health model, where it can be detecting the anomalies, failure prediction can also be there in terms of AI ML applications, and also the conventional algorithm. And so basically integrating all different assets into a larger set of assets, whether it's a substation feeding to the urban grid or to a particular complex commercial or industrial within the city. So this is important to have the complete asset management system, and also use image, video in terms of having the non-intrusive kind of video and images to monitor the assets. One example is that here you monitor the substation assets with the intelligent cameras, and then also the thermography, and see that where you have some malfunction or maybe any trend which can lead to failure of asset or malfunction of the asset. So this is in addition to the direct sensors what we put in the substations and equipment. Digital substation is one another area which is very important for urban areas. Digital substation, and also as Sohail talked about the GIS, for example, the gas insulated switchgear in the urban areas to reduce the space, and also contain it within the smaller space in the city, but at the same time having the digital substation so that the assets can be monitored better, and also the time for installation commissioning can be reduced in And digital twin, virtual reality, this is where this will also help in sort of training the new generation of workforce in the electrical installations, and also see the installation, the asset health, monitoring them virtually, remotely, and also ensuring that the system, the grid is up and running all the time. And also augmented reality, using it for diagnosing any problem in any asset, whether it is a 3D model, thermal imaging, thermography, and asset performance models, all those things, and also connecting to the remote experts. So this is how the technology can be used. And what we also do here, basically having the conventional system, whether it's a substation or installation or even distribution line. So here, the additional sensor support, and also use the digital technologies, as I talked about, different technologies to ensure that we can improve the productivity, reliability, asset health, energy efficiency, safety. And so finally, it is also that how these the condition of the assets and the system, they're available from the control room to the boardroom to so that, and also in the different phases of the installation while planning, building, operating, and maintaining, which is important for the performance of the assets in the systems, the grid in electricity 4.0. And when it comes to how we have to do it, approach it, I think it has to be done right from the planning, building, and operating phase. But at the same time, if you already have a system, you can also create a digital twin. If it is in the operation phase, you can create a digital twin, and also that will help you to maintain. But whenever you upgrade, you can use always this digital twin to simulate the upgrade condition, and then see that you are achieving the performance from the core system and core assets as well as the digitalization. So the question is always where to start from. I think very important is to define the KPIs, the key performance indicators, what you would like to achieve, and then do the assessment, benchmarking of what core technology, what automation technology you want to use to improve the KPIs, and also what digital solutions, for example, asset performance or work performance, workforce performance improvement you can achieve. And then you can do the monitoring through the digital systems, through the control room, and then you do continuous assessment, benchmarking. So this is a continuous activity. Many people think that like industry 4.0, when we can achieve industry 4.0. So it's not a, it's a journey. Basically, you have to plan, you define the KPIs and achieve it on a continuous basis every 6 months, every 1 year, every 2 years, because the technologies will be changing, and also you have to implement them. At the same time, you cannot disrupt the electricity is very important, lifeline of the society, community, industries, infrastructure. So you can't even have a second of interruption. So while the technology is upgraded, coming, and you have to implement them, so the system also has to run without any loss of efficiency. So that's why it's important to understand that electricity 4.0 can happen on a continuously improving approach rather than one go. One go you can have it in the new project, greenfield project, but we have the system already running. Then in that case, it's always a improvement on a continuous basis.